Okay, so I want to go over this worksheet. Basically, it's just scaffolding to get you ready to do the lab. Real simple. We're going to use this equation, Q equals mc delta T. This is heat. This is the mass of the water that's being heated in this case. This is the specific heat of water, which is going to be 4.184. This is the change in temperature. And so basically, just to kind of go over what we're going to be doing with the lab, is we're going to have a chip burning under a soda can filled with water. And basically, let me pick some different colors here. And clean this up a little bit more. So basically, this right here, again, is the heat, and that is going to be in joules, unit of energy. This is going to be the mass of the water, and for our experiment, I believe it's 50 grams of water. And this is the change in temperature. So whenever you measure the change of something, like say let's just talk about change of the letter A. What you're going to do is put the value of A final, that's like where it ends up some later time, and A initial. So when we talk about change, if A final is bigger, this one right here is bigger, then you're going to have a positive answer. If something is shrinking and A final is smaller, you can see that you're going to have a negative answer. For example, if we start out with initial of 250 and you wind up at 200, then the difference is going to be negative 50 because this side is bigger. So that's how it works. And this is pretty straightforward because you realize that if you burn a chip underwater, it seems kind of common sense that if you measure the temperature, there's going to be a delta T. The temperature is going to change. Okay, so let's go back to what we're working on here. So let's do some calculations with some real numbers. So we're going to use 50 grams of water, and it's going to start out at 21 degrees, and after we burn the chip, it's going to be 34 degrees. Well, in this case, it's a candle, sorry. If we measure the mass of the candle and the tinfoil it's setting on, it starts out at 5.10 grams. And then after burning still on the tinfoil, it's a little bit lighter. It goes down to 4.92 grams. So there's a little bit of a difference. So we know that that was basically consumed by the fire, that little difference. So let's go ahead and find the delta T. So we do the final temperature first, remember what we talked about. So it's 34, and the initial temperature goes second. The difference between this is 13 degrees. To calculate the Q, we just simply multiply the mass of the sample of water that we're heating. We already have the specific heat of water, 4.184 there. Delta T is just from this line above here, so we just carry it down 13 degrees. And if we multiply this together, let's grab the calculator. That's going to be 50 grams of water times the specific heat of water times the change in temperature. That's 13 grams. So that's 2,000, and if we round, 2,720. So let's go back. 2,720 joules. That's a unit of energy. Okay. Then we want to find out, well, how much energy is generated per gram, so we can find the energy density or of the burning candle. So remember, we put the final mass first. So that's 4.92. And the initial mass is 5.10. That's going to be negative. If you bust out the calculator again, or you can just do it, longhand. You'll see that's negative 0.18. So we lost 0.18 grams. So then in order to find the energy density, we divide the energy released, 2,720, by, I'm going to drop the negative because I just want to, I want the absolute value of this. That's more useful to me. So I'm going to take this and go ahead and divide. So divide this by 0.18. It's 15,109 joules. So 15,109 joules. And that's basically how to do these calculations. Go ahead and answer these questions, and then go ahead and answer these bad boys too. That's all I have.